when you are working at the low temperature, any low temperature calls for us a thin layer of hydrocarbon on the tray. Upon the amine, we have a thin layer of the hydrocarbon and forming stuff. But when we increase the temperature of amine, we can conclude if we increase temperature, it's better for us. But if we consume amine enters to the tower by the temperature of 90 degrees centigrade in this condition, the high temperature increases the temperature of the gas. When the temperature of gas increases, more water carry over from here. More water carry over from the gas here. Also, the size of bubble increase on the trays and foaming start sooner. Therefore, we have to find the optimum temperature for amine. It's better to keep it between 40 and 50. The best amine temperature is 45. And also, we have always keep the temperature of amine 10 to 15 degrees centigrade upper than inlet gas to prevent condensation happening. We know always we consider that the lower temperature, higher pressure is better for absorption. But the lower temperature make problem for us in the absorber. Therefore, we have to put it away. Optimum temperature is best. You have a question?
So, Ali, some of the problem there is oil demister. This can help us to reduce the level for the next
A thin layer of oil appear on the trays. We cannot remove it. In the oil demister pad, in the first step of the amine sweetening, we have an oil demister, oil separation. Then we have a qualiser filter. In the oil demister, we give the gas a little bit pressure drop to liquefy all the hydrocarbons. And after that, in the qualiser, fine particles, solid particles catch from the gas at that stage. After that, when the gas is clean and without any heavy hydrocarbon enters into the tower, the condition is very excellent for sweetening. If you increase the temperature of gas or decrease the temperature of gas, condensation happens on the tray. We cannot do anything over there. If we want to completely remove the gas, if we want to completely remove a hydrocarbon from the gas and then enter it into the amine unit, you have to build an NGL, LNG or an exchanger to reduce the temperature. Completely catch the hydrocarbon from the gas and after that enters to the sweetening. The price of this exchanger is too high because it should be resistant against the H2S. I explained it yesterday from economical point of view. We always try to working at the border, the best efficiency. Like working nearby the surge in the compressor. The surge point is the high efficiency working point for the compressor. But a little bit far from the surge point is the best working point. In these towers also, we just consider that we have to keep the amine temperature enough high to prevent this thin layer formation. Without any exchanger installation like this one. Okay, you know about the water content? Water content. The water content is the capacity of any fluid can carry water. Some fluid has a higher capacity of the water carrying and some fluid has less. If you increase the temperature for each fluid, the capacity of water carrying increase. Therefore, we have to always consider if the temperature of amine is too high, more water absorbed by the gas and going to the next step in the dehydration unit. Increase the temperature of amine, has a side effect into the downstream unit. Increase the water carried and enters to the dehydration unit. Therefore, your dehydration unit start to working on their interruption. Make interruption for the next unit. You have to consider that each increasing 1 degree centigrade, if you increase about 7 degrees centigrade of the gas temperature, that means 22 enters and 29 leave the turbine. The load of water enters to the dehydration unit increased by 2 times. By 2 times. Very high. Therefore, temperature controlling in the absorber, more of the controlling the foaming effect on the next unit. Therefore, we have to consider always about that.